Hello everyone, this is Dr. Sirisha working for Institute of Aeronautical Engineering College. Today is day 2 for Accenture. Today we are going to deal with few more pseudo codes for the first round of Accenture. Accenture is one of the prominent companies which recruit freshers in a lot, right? So in this company specific training sessions, let's start with a few pseudo codes, right? So let's begin with the first one. Have a look at the pseudo code. Here you can see they have given a function, guys. This type of function, this is the pseudocode in general, right? So in general, in any pseudocode, they'll give the name of the function is a piece of definite, and then the return time and the parameters and their data type. So it is a pseudocode which has been beautifully designed, and Accenture mostly goes with pseudocodes. You can see and refer previous papers also where they rely on pseudocodes rather than bits and pieces of any other programming language like C or C++ or Java, right? So but they concentrate on the basics of any programming language, right? The basics of programming, I can see. That means it deals with the data types, the operators, the loops, the working of the basic control structures, right? All these things they deal with. So you need to be strong in the core to crack Accenture's first round, right? So let's start with the first one. Here you can see that there are two variables, A and B, which are initialized to 4 and 9 respectively. Okay, so let's start the manual tracing of this program to get the result. As in the first round, you all know you'll not be provided with any software, or you'll not get in aid of any programming language, right? Like either Python or say nothing. You have to manually trace it to get the output, right? So your brain must act like a compiler or an interpreter. Right, let's start. Have a look at this function. The name of the function is fun. So within the body of the function, you can again see that there is a function called with the same name. This tells you that this is a recursive function, not an ordinary one. A recursive function is a function which calls itself, right? So let's start tracing of the same. I think it is going to run a long way. So I'll start from the top. So initially the function is called on the name of 4, 9 with the values 4 and 9 as the values. So 4 for A and 9 for B. Right? So the first statement in the body of the function is a condition. Right? A condition which checks whether A is less than B or not. So 4 is less than 9 or not. Yes, the condition is true. As the condition is true, it is going to return the value. The return will be, or let me write rather than taking the word, keyword, 1 plus the function call of A. A value is 4 and B minus 2, which is 7. 9 minus 2, 7. It is calling itself. So let's evaluate this one. If we evaluate this one, again the body will start executing itself. So 4 is less than 7. Again the condition is true. So it is going to return the body of, if will be executed, that is going to return 1 plus fun of A comma B minus 2, that is 7 minus 2, which is 5. So again, this is the function call. Again, the function will be called with the values 4 and 5 respectively for A and B, right? So here again, the condition will be checked. It says 4 is less than 5 and the condition is true. So as the condition is true, it is going to talk about return of 1 plus the function fun of 4, that is A comma B minus 2, that is 5 minus 2, which is 3. Right? So again here one more function called recursion. I hope you can see the structure, right? So this here it will be 4 minus 4 is less than 3. Here the condition fails. Here the condition in this recursion, the condition fails. If the condition fails with the value of a with 4 and b with 3, the remaining body of the function will be executed. What is the remaining part? The remaining part is an if else structure, right? So let's go with evaluation of this structure with a as 4 and b as 3. Here is the condition which is checking for a XOR b is greater than a and b. Here a value is 4 whereas b value is 3. So a exponent b. These two operators XOR and bitwise and both are bit level operators. That means whatever the value that is initialized to them will be converted into ones and zeros, that is into binary system. Operation will be performed by LU and the resultant will be again converted to decimal and reverted, right? So let's calculate the same and let's check whether the condition is true or not. So if you convert A, that is 4 into binary, you'll get 0, 1, 0, 0. Coming to B, it will be 0, 0, 1, 1. An exponent operation of these two will give you the result as 0, 111, which is equal to 7. Because XOR says that if the inputs or the inputs which it's taking are different in nature, then the result will be 1. If they are same, it will be 0. So the first step in the first bits, MSBs in A and B are same, similar. So the result is 0. For all the remaining, it is a combination of 1, 0 or 0. So the result is 1. Let's perform another operation, which is bitwise AND. Bitwise AND says that if both the inputs are 1, the result will be 1 or else it will be 0. In all the remaining cases, it is 0. We can easily say that you will not find any case where the A bit and B bit are ones correspondingly. No. So it will be all zeros signifying the value 0. So this is A cap B and A and B the results. So if you replace them in the given condition, if we replace this in the given condition, you can see that 7 greater than 0. The condition is true. As the condition is true, it is going to return the value A XOR B. What is the value of A XOR B? Just now we have calculated, it is 7, right? So why we calculated this? For this purpose, right? For check for the function. This is the function call where we went for the calculation, where the condition, that is A less than B, the first condition failed, right? So let me erase the failure case. Okay, so overall the function with the values A and B with 4 and 3 respectively will give you a return value as 7. Well and good. Who called this function fun of 4, 3? Function 4, 5 have called it, right? So what value it is going to get in return? It is going to get in return get the value 1 plus 7, which is 8. I hope I'm clear. Then next point, we are going in reverse direction, backtracking the things, right? Who called this function 4, 5, right? It was called basically by fun of 4, 7. What is the result of these two? 1 plus 8, 9. 9 will be the return value for the function 4, 7. Then who called 4, 7? It is called by the the first call, that is fun of 4, 9. So the return value of this 1 plus 9, 10 will be returned to the basic function call 4, 9. Have a look at the basic values. So A is 4, B is 9. The story started there with the values of A and B, 4 and 9 respectively. So what is the end result it is getting in return? Value 10. So the answer is D, 10. Let's have patience and evaluate it. I elaborately explained you. If you work on it, it will be easy for you. So this whole problem is the pseudocode is a recursive function where you can see relational operators, bitwise XOR and bitwise AND operators. Okay, so I hope this is clear. Let's go for the next scenario. Have a look at this one. This is a quite simple one, right? Here again they are taking two values for A and B and they are initialized with 4 and 6 respectively. Okay, so even here the function which they are talking about is a recursive function. Just have a look at this one. Fun is calling itself. Even this is an example for recursive functions, right? So let's start a manual tracing of this one. So the value of A is 4 and B is 6. So if the first condition, the first statement in the body of the function itself is a condition to check the condition. If 4 is greater than 1, the condition is true. Am I right? So if the condition is true, the body of if is a written statement will get executed. What is that? What is the value of A? Sorry dear, it is 4 multiplied by fun of B minus 6. What is the value of B? It's 6. 6 minus 6 comma A. 4 minus 4. Which can be converted into 6 minus 6 is 0, a big 0, and 4 minus 4 is again a big 0. This is a function call, right? So let me evaluate this function. So it will in return check. So here the value of A is 0 and B is 0, right? So is 0 greater than 1? The condition fails. If that condition fails, what will happen? Else part will get executed. What else part is saying? Else part is saying to return 1, right? So as a whole, what is the result of this whole function call? It's 1, right? So who called this function? The function of 4 comma 6 have actually called this one, which will get in return 4 into 1, that is 4 into 1, which is 4, right? So the result of the function which is having the parameters 4 and 6 is 4, option C. Yes, there is a small lesson to learn in this function. Just have a look at this. See, here if you talk broadly about this one, the body of the function is having an if-else structure, and this will be collectively a compound statement, statement 1, and the second one is a written statement, right? If condition is if control structure is a conditional control structure, which will be either true or false. And this structure is having an else part also. So whatever the value of A may be, because A is the only part and parcel of the condition, so the structure totally relies on the value of A, not B, right? So whatever the value of A may be, either the condition will be true or false. That means either the first written statement will be executed, which is the part of if, or the second written statement will be executed, which is the part of else part. This statement 2, that is written of A plus B, will never be executed. So you may take various values for A and B and check whether will you get any case where this second statement will get executed. It will never get executed. So the condition will be either true or false. So if it is false, it is having another line that is the else part. The control will move to that part. Okay? Yeah. Let's go to the next one. It looks a bit lengthy, but it's quite easy, guys. A simple pseudocode is given with 3 values. Let me take in memory. Because there in the set I cannot erase the things. Here I can do. Q is 30, P is 10, and R is 20. Let's say or assume that this is our memory space where the data of Q, P, and R are initialized in this fashion. Okay, so with the set statement, I have built that. Let's go with the if condition. If condition is saying or checking whether R is greater than R plus P. So let's replace the values. R is 20, 20 greater than 20 plus 10, 30. So it is wrong, right? 20 is greater than 30, it's false. So else part is going to get executed. So what is the body of else saying? Else is saying that override the value of P with P minus 2. So now the new P will be 18. P, the actual value of P is 10, guys. So 10 minus 2, 8. So in the memory, 10 will be overwritten by 8. Similarly, the Q again is been reduced by 2 units. That is 20 minus 2, 18. Okay. So even in the memory, R will be overwritten by 18. So whenever in the further calculations, whenever I'm going to do any calculations, I'll fetch the elements or the values of PQR from the memory, not from the set. Set means initialization. Once initialized, the data can be changed at any point of time or at any piece of code, right? Because they are not global constant. They're not constants, right? So this, as you can see, this pseudocode is having 2 if-else structures that we have just now executed the first one. Let's talk about the second one. Remember, conditional control structures. The first one is if. Decision-making statement will always get executed only once. It is going to check the condition only once. If it is true, if part body will be executed. If it fails, else part body will be executed. Okay, so now as the first structure is done, let's go to the second structure where it is talking about R greater than Q plus P or 1. So here it is a combination of relational operators, relational and logical. So let's replace the values. R is 18, guys. I'm fetching the values from memory. Q is 30 plus 8 or 1. So coming to the precedences, first of all, logics will be executed and then relational. So here you can see that whatever the value, 38 or 1 or any value, if it is other than 0, it is true. Remaining all are false. So true or true will give you the result as true because it is an OR operation, logical OR operation, which says that if at least one condition is true, the result is true. So 18 is greater than 1, the condition is true, guys. There is nothing wrong in that, right? So as the condition is true, so you are going to evaluate the value of Q. So Q is equal to 0 XOR 5. So as I said, they are bitwise operators. So let me convert 0 and for 5, 0, 1, 0, 1. So XOR operation tells that if they are different, it's 1. So 0, 1, 0, 1, it's 1. Right? So there is no change in the value. So okay, even this part is done, and the result is been assigned to Q. So in the memory, 30 will be overwritten by 5, guys. 30 is overwritten by 5, right? So yes, now both the if-else structures are evaluated. Now the last statement. This is the third statement. The first structure is one compound statement. Second is a compound statement. Third is a print statement. Right? A simple statement. It says to print the value of p plus q plus r. It's 31 because 5 plus 8 plus 18, 31. Okay, just some of these guys 31. Okay, simple tracing we have to do. Here you can see how many operations are there: logical or bitwise, relational, arithmetic operations, many operations. But simply trace it. Have a look at this question. It's a simple pseudo code, which here till now the first three snippets we have seen on decision making statement. If right, so let's move ahead and go for loops, right? So let's start this loop. So here the loop is saying that for each count is just a variable, is going to run from 0 to 9. Okay, so that is for, if you convert that into count, yes, count is initialized to 0, count less than or equal to 9, count plus plus. If you convert that into C, or if you convert that in Python, count in range of 0 to 10, because I'm talking about range. So 10 will be the stopping point, and they have asked me to go with the 0 to 9. So 9 I have to include. If I want to include 9, then I have to take the stopping criteria as 10. See, even in C I have used equal to, less than or equal to. Okay, fine. Let's trace the code. So initially, so here they have used unconditional control structure continue. Okay, as the body of the inside if, right? Right. So initially the count variable is holding 0, and 0 is less than or equal to 9. You have to check the condition. Let me write the condition. This is the condition. Count must be less than or equal to 9. Okay, the condition is true. So let me make a frame so that I'll show you what the output line is going to print. So the first statement, the condition is true in the body. The first statement is hash, right? Very good. Then it is checking for the if condition, which is saying, is the count greater than 6? Yes, 0 is greater than 6. It's fails. So the continuous statement is not going to work. It is going to print the count, which is 0. Once it is 0, again, as it is a loop, the control will again go back to the first statement, where it is going to increment the value of count, which is 1. Again, the print statement hash. Again, the if condition, if the count value, which is 1 right now, is greater than 6, the condition fails. The continuous statement is not going to get executed, and it is going to print the count 1, right? So again, the for loop, the increment, the updation part of the for loop, where it increments it to 2, and within the body you have the hash to be get printed first, then the count, that is 2 greater than 6. The condition fails, count is not going to get executed. You are going to print the count value. And this story goes on until unless the condition given in if fails, or the condition given in the for loop fails. Either this or that. To come out of the loop, the condition in the for loop must be broken, or if you want to reach the continue statement, the condition given in the if must be true, right? So have a look at the condition. It is saying that count is greater than 6. So when will this condition is true? Only when the count value is 7. Am I right or wrong? When it is 7, the count 7 is greater than 6, the count is true, right? Till then, the process goes on. That means it is going to print till 6. Then hash, then the condition comes true, which invokes the continue statement, which is an unconditional control structure placed in loops, right? So what is the job of continue? To break the flow and take to the loop in which it is being placed. So it is not going to take you to the print count statement. It will no longer get printed. So it will keep on printing just hash, because print hash is a statement which is before the condition checking, that is count greater than 6. Before you check the condition, you are printing hash. There is no problem in that. So for 7, 8 and for 9, it is going to print 3 times. So once the count value is 10, so the condition which is placed in our for is going to get failed, because the condition is less than or equal to 9, guys. So if the count reaches 10, it breaks and you come out of the loop, right? So this is the pattern that is going to get printed. So which one matches this one? It's B. So B is the answer. Yes, remember, continue is an unconditional control structure which will take you to the starting of the loop in which it is placed, and they are used only in loops. You cannot use them in decision making statements, right? Let's go for the next one. A simple calculation, guys. This is a simple pseudo code which is going with modulo division, overwriting of the values. Just you have to be aware of how the data is being overwritten. So if you take the values in between values or the initialized ones, then the answer is going to backfire you. Okay, so I'm taking a piece of memory. Okay, so in which the value of A has been initialized to 50, B as 23, and C as of now with nothing. Okay, in the initialization part, that is the first statement I'm talking about. Okay, so let's start the calculation. There is no loop, no decision making, nothing. Simple calculations. Let's do that. C is being initialized with the value A plus B. That is a sum of these two, which is 73. Okay, fine. The next statement, C is equal to C mod B. It is nothing but C mod B, guys, which returns the remainder. Okay, so C is, you have to fetch the values from the memory. So 73 modulo division with 23. So if I am not wrong, the answer is 4. Okay, so the answer is 4. So C value in the memory will be overwritten by 4. Okay, the statement got executed. The next statement where it is saying B is equal to B plus C. Fetch the elements, fetch the latest elements from the memory, which is 23 plus 4, which is 27, which is in overwritten. So 23 will be overwritten by 27 in memory for B. Now, the last but one statement, which is saying A is equal to A minus B. Retrieve the values from the memory, guys. Okay, so the value of A is 50 and the value of B is 27. So the value is 23. So in memory, 50 will be overwritten by 23. And the last statement is asking you to print the values of A, B and C. So 23, 27 and 4. It's quite simple. No, this looks like a simple question, but where the people go wrong is, once calculating after this, if they start calculating this line, they fetch the value from here. rather than from the memory, which is supposed to be 27, they take 23. No, it's not that. Yes, you may think it's simple mathematics, but at the time of placement, guys, it's a crucial time. Everyone will be a bit tensed. With tension, these things go on. Even though they are silly mistakes, they are a bit costly at times. If loads of people are writing the same exam, even this bit will be a costly one. So let's go for the next one. Yes, here arrays are being introduced to you guys. Okay, so m is an integer value and which is set to 0, and whereas p is an array of integers of maximum size 5. So any array, its name followed by square brackets and the size within it. This is the basic syntax. And data type, even let me take that data type. What type of data it is going to take, the name, and within square brackets the maximum size they can accommodate. Okay, so here you can see that p is the name of the array and it takes integers values and its maximum size is 5. So p, so I hope you all know about index values. Okay, so 0, 1, 2, 3, and 4. These are the index values of the elements placed in the array, right? So here you have two if statements. There is no else part. If the condition is true, the body will get executed, or else nothing is going to change, nothing will get evaluated because else part is not there. So if with the condition is the first if structure and the second one is this structure. Let's evaluate them both. The first one is saying that p of 0 logical end of p of 4. So if this returns true, then m value will be overwritten. What is the value of m in our memory, guys? It is 0, right? With the set statement, it is 0. Let's see. So p with index value 0 is 1 and p with index value 4 is 7. So both are some other values other than 0. So true and true, it will return true. So the condition is true. So the m value will be overwritten by p of 1. What is the value of p of 1? It is index value 1, it is 1. So in the memory, 0 will be overwritten with 1. Okay, the first if statement got executed. The second if statement is talking about p of 2 and p of 3. Let me check whether it is true or false. P of 2 is 0 and p of 3 is 1. So as I said, everything is true. 1 is true, but 0 is false. And logical end always says that all the statements must be true. If at least one is false, the whole condition is false. So this is false. So m being reinitialized will not happen. Okay. So in these two if parallel statement, the first condition is true, second one is false. So yes, the job is done. As I said, if statements will be executed only once, the condition will be checked only once. So the last statement is to print the value of m. Retrieve the value from memory, guys, and value is 1. Right? Very good. I hope you got this. Let's go for the next snippet, which is similar to this one. Have a look. So with arrays, I have even introduced for a combination of that, guys. So m is being initialized to -1 in memory. That is the first point with our set statement. Okay, and the array a of 5. So the values in it are 3, 0, 1, 0, 2, and the index value is 0, 1, 2, 3, 4. Right? So these are the values. So the loop runs for j. It has been starting from m plus 1. What is the value of m? It's minus 1. Minus 1 plus 1 is 0. So it will start with 0. And the condition says that till m plus 5, that is minus 1 plus 5, which is 4, that is less than or equal to 4. Between values 0 and 4, including 0 and 4, the between values they are talking about. J is less than or equal to 4, and obviously the value of j will keep on incrementing, right? So let's how it is going to get evaluated. So initially the for loop, as you all know, this is the for loop, the whole structure of the for loop, and it is going to start with j is equal to 0, and a of j and j is the condition which we need to check within the body, right? When you go with the checking the body, right? So a of j is initially a of 0 is 3 and j is 0. So bitwise an operation of these two, 0, 0, 1, 1 and 4 zeros will be, and an operation of these will give you a value 0. That means the condition fails. So the body of the if condition, it says a of j, this assignment will not get executed. Okay, fine. Then let's go with the incrementation of j. Now the value of j is 1. Okay, so if the and the condition is also true, 1 is less than or equal to 4, fine with it. A of 1 and 1 is the condition which you have to check. A of 1 is 0 and 1. So let me convert it into bits. 4 zeros, 0, 0, 0, 1. And an end operation of that will give me a 0. That is a failure case. Even for j is equal to 1, the body of if is not going to get executed. Let me raise the value of j, right? So because in the for loop, the body of it is only if condition, nothing more than that. So j value is 2. So check the condition, a of 2 and 2. So a of 2 is 1 and 2. Let me write the bits of the same. If you perform and even this is 0, bitwise n says that both must be true, and you will not find a single case where it is true. So even for 2, the bit is not going to change. The a of j value is not going to change. For 3, have a look. A of 3 to override. So a of 3 and 3. A of 3 is 0 and anything. Please remember guys, 0, bitwise and anything will give you the result 0. Again the condition fails. Let me go with the last case where the value of j is 4. So a of 4 and 4. So a of 4 is 2 and 4. So 0, 0, 1, 0, 0, 1, 0, 0, and an end of that will give you a value 0. Even for 4, j value 4, the body of if will never get executed because this condition went false in all the cases. So by the end of for loop, we have seen that no value of the array are being changed. Nothing. So the last statement, but one statement, that is the initializing the that overwriting. Let me say that override for to override the value of n. They have taken a of 0, which is 3, a of 4, which is 2, minus a of 1, which is 0, which is 5. And the last statement is to print the value of m, which is 6, that is 5. Right? So this is how we trace the program, guys. So I hope this session was useful for you. I'll meet you in the next session. Keep watching. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.